Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the synthetic division, remainder, and factor theorem. Now, first of all, why we are using the synthetic division? Suppose if you want to divide a number, so if you have a number 5 over 2, so how will you divide this one? So we can divide as 5 divided by 2, it is 2 times, which is 4, remainder is 1. Now this one, we call it this one as a divisor D, and this one is my remainder R, and this is the quotient Q. So how will you write this number in the mixed fraction, improper fraction? So I can write it that one as Q R over D. So it is equal, so 2 times of 2 over 1. So if you cross multiply 2 into 2, 4, 4 plus 1, 5. So you will get 5 over 2. This is the 5 over 2. Suppose if you have the polynomial x to the power 3 plus 2x square plus x 5x plus 1. If you want to divide this one by a binomial, this one you can do it by using the synthetic division. And the synthetic division we are using in all the topics. So we will use to solve the problem of the synthetic division problem and the remainder theorem, factor theorem, and finding all zeros. We are using the same technique of the synthetic division. Now let us solve the first problem, how to solve the problem using the synthetic division. Now this is the polynomial is given and it is divided by the x plus 4. Now I have to check whether all the term will be there. So see here, this is x power 4, but x power 3 is missing. So I write it this one x power 4 plus, therefore this x power 3 is missing. I write it 0x power 3 minus 4x square plus 7x plus 14. If you write it in the order, it should be in the decreasing order. See here, 4, x power 4, x power 3, x power 2, x power 1, and a constant. Now it is complete. Now I will start the process. The first one, I will go with the synthetic division. Take the coefficients. What are the coefficients here? You will have. The coefficient is 1, 0, minus 4, 7, 15. So I write it here 1, 0, minus 4, 7 plus 15. Now I have to divide this by the factor x plus 4. Whenever you will have a plus 4, I will use the minus 4. You have to use the opposite sign here. So x is equal minus 4. I will use the minus 4. If it is minus, I will use the plus here. Now, the first one is 0 for all the problem. As it is, add it as it is, you will get 1. The same addition. 1 plus 0 is 1. The next one, I will multiply this one. When you multiply this, what will get? So here, we will have minus 4. If you add minus 4, it becomes minus 4. Minus of minus, it becomes plus 16. So this is actually, you have to multiply again the same thing. You will get this part. Now if you add it again, you will have 12. Now multiply the next one. Multiply the next one. You will have 48. 48. So if you add, it becomes 55. It becomes 55. Now when you multiply with the minus, it is minus, sorry. Here you will have minus, right? So when you multiply with the minus 4 into 12, it becomes minus. If you subtract, you will get minus 41. Minus of minus plus, therefore it becomes 164. It is a 164. So this is the last part. I will multiply this, then you will get this part. And the last one is my remainder. If you add it, you will get 179. Now here, this is my quotient Q, and this is the remainder R, and this one is the divisor, that is D. So how will you write it? This rule. So same thing as what we have done before. So this is the same thing we will do it. So it is Q plus R over D. So how will you write this one? So polynomial P of X is divided by the divisor X plus 4. It can be written as quotient. And one more interesting thing here. Whenever you will have x power 4, this is reduced to x power 3. This one is x power 3. So therefore 1x power 3 minus 4x square plus 12x minus 41. So always one number reduce. If it is x power 4, this will start x power 3. If it is x power 5, then it is start with x power 4. So one number will be reduced here. Then plus R. What do you the R? What is your R? 179 over what is the divisor? That is the question. What we have? X plus 4. So this is the division form of the polynomial. If you divide this polynomial, you will get in this format. Now we will solve the same another problem with the same rule, synthetic division. I have to divide this one x power 4 plus 1. But here there is so many terms which is missing. What are they? X power 4. Then what is the missing here? 0x power 3, 0x power 2, 0x. And the last term, the constant term is there. That is the polynomial. This is my polynomial. It is divided by the factor x plus 1. Now start the process here. I will just solve this one with the coefficient. What is the coefficient here? You will have 1, 0, 0, 0, 3, 0, 1, 0, 0, 0. At the last constant is 1. Now I have to start the process. To start the process, we will have the opposite sign. If it is plus 1, it is minus 1. The first value will be 0. Add it, it is 1. Now start the process. What is the multiplication? Minus 1. It is minus 1. Addition. Minus of minus plus 1. Add it, it becomes plus 1. When you multiply minus 1, add it, it becomes minus 1. When you multiply, it becomes plus 1. So answer will be 2. So let us check one more time. This is 1. Multiply minus 1. Add it minus 1. Minus of minus plus 1. Add it plus 1. Minus 1 into plus 1. It is minus 1. Add it minus 1. When you multiply minus with the minus, it becomes plus. Therefore, it's a quotient. Now, this is my Q. And this is R. And this is the D. So how will you write? So I write it this one as Q plus R over D. So what is Q? The Q is x power 4. It is reduced to x power 3. So it is 1x power 3 minus 1x square plus x minus 1. So this quotient is over. Now the next one R. R is 2 over x plus 1. That's it. So this is the synthetic division. We are using the same thing throughout the chapter of factoring theorem and remainder theorem. Now we move to the next topic, which is a remainder theorem. What is the remainder theorem says? So if your polynomial p of x is divided by the factor x minus c, then the remainder is equal to p of c. So let us check with the problem. Here we will have so this one, it is directly c is given. Whenever c is given, no need to change the value because it is given directly the value of c. Whenever c is given, so no need to change the value. When it is given in the factor x plus 2, then you will change the sign. So here, now we will start this one. The first one, I will take the first one is c is equal minus 2. What is the answer? So here, so I want to check first 3, 2, 1, 0. There is no missing term. So I will go with the coefficients. What is the coefficients here? So it is 2, 3, 2, minus 2. And here I will take as it is. Why we are taking as it is? Because it is given as a C, not as a factor. Whenever it is given as a factor, change the sign. Whenever it is given C, directly you take the same thing without changing the sign. So the first value will be 0. When add it, it becomes 2. Now start the process. What happened? Minus 4. Add it, minus 1. When you multiply minus of minus, it becomes plus 2. Add it, plus 4. When you multiply, it becomes, you have minus 8. So answer will be minus 10. So the remainder theorem says the P of minus 2 is equal minus 10. So this is the remainder theorem says. Let us check with the regular method what we done. Regular method, what we'll do, just I replace the C value in place of X. What happened? Let us check. So minus 2, I just substitute in the polynomial. You will get 2 times of minus 2 power 3 plus 3 times of minus 2 power 2 plus 2 times of minus 2 minus 2. I replace minus 2 in the polynomial. Let us check what happened. Here you will get minus 8 since it is an odd power. 3 times of minus 2 power square, it is the even power plus 4. Here minus 4 minus 2. Now what is the answer here you will get? It becomes minus 16 plus 12 and minus 6. I've added these two. Now what happened here next? So it become minus 10. It is minus 22 plus 12 which is equal minus 10. Are you get the same answer? Using the synthetic division, the remainder is 0. And this is, if you substitute the value, it is a minus 10. That is what the remainder theorem says. The remainder is equal P of C. So this is the remainder theorem says. So this one is the easiest one. We can do it. But sometime we make use this one. I will tell you when you have to use this one. Now, the next one I will start with the half. Phi is equal half. Let us start with this one here. We'll have 2, 3, 2 and minus 2. And start with the value half. And the first value will be 0. Add it, it will become 2. Multiply with this one, it is 2 to get cancel 1. Add it 4. Multiply, it becomes 2. Again it is 4. Multiply, it becomes plus 2. And the final value will be 0. Now I will say P of half is equal 0. The remainder is 0 when you substitute the half. If I substitute the same c equal half in the polynomial, at the last you will get the same thing as a 0. This is no need. This is only for your verification. I just do it two things. Only you will do it the synthetic division, finding the remainder theorem, the remainder using the synthetic division. It is more than enough. Now we will have two more problems like the same thing, but here there is a missing term. Here you will have some missing term. What are the missing term? X power 3 is missing. Here x is missing. So I will just go with this. X power 4 is 1, 0 because x power 3 is 0, minus 6 x square and x is missing again. So you will get 5 at the last. So these two terms which is missing. This is what? X and x power 3. That's why we will put it 0. Now the C value, I don't change the sign. I take it directly minus 2. Now start this one. 4 multiply, it become minus 8. Add it, minus 8. Minus of minus plus 16. Add it, plus 10. Multiply, minus 20. Add it, minus 20. Multiply, it become plus 40. So the answer will be 45. So I will write it here. P of minus 2 is equal 45. No need to check it here. Since it is the first problem, I show it whether you will get the same thing. But thereafter, use a synthetic division, directly find the remainder. Now the next one, here. Here the synthetic division fail. If you do it this one, it is 100, x to the power 100. That's why we will use this technique to prove this rule. I will not use the synthetic division because it is x power 100. How will you solve this one? So that's why it is a very long using the synthetic division. That's why I just use this technique. I just substitute here minus 1 and get it the answer. Minus 1 to the power 100 minus 4 times of minus 1 to the power 45 plus 5 times of minus 1 to the power 30 plus 10. Now since this is a even power, you have plus. This one become plus 1. Now this is a odd power. You will have minus 1. So I will have 4 times of minus 1 because it's the odd. And since it is a even, plus this is a even number, you will have plus 1 plus 10 plus 10. Now I will simplify further. It becomes 1 minus of minus plus 4 plus 5 plus 10. So it becomes, this is 5 plus 5, 10, 10 plus 10, which is equal 20. So this is very easy if you go with the substitution method. So the synthetic division is very long. Why? Because of the power. It is 100, x to the power 100. Okay. Now the next one is the factor theorem. What is the factor theorem says? If a polynomial is have a factor, this is a factor means if and only if the remainder must be 0. Always if the remainder is 0, we will say this is a factor. If it is not 0, we say it is does not as a factor. Let us start with the first problem. So I want to check the given factor x plus 5 is the factor of the polynomial. How will you check? So I will go with the synthetic method. So I have to check whether there is a missing term. If there is missing term here, x power 4, 3, 2, 1 and constant. No missing term. I will just take the coefficient 1, again 1, again 1, minus 21 and minus 1 and 20. Now I have to start this one since it is given along with the x, I have to change. So it is minus 5. Now 0, I'll start this one 1, multiply, you will get minus 5. Add it, it become minus 4. Multiply, minus of minus plus 20. Minus 1, multiply, it become plus 5. Add it, it become plus 4. When you multiply, it become minus 20. So the answer will be 0. Now I got it. P of minus 5 is equal 0. That means that the remainder is 0. Whenever remainder is 0, we will say it is a factor. Otherwise, it doesn't the factor. It is not a factor of the polynomial. So I will say x plus 5 is factor of p of x. P of x. So if you will not get the 0, I will say it is not a factor. Let us take the next problem. X minus 2 is a factor. I have to check this binomial is a factor of the polynomial. Let us check. I start with the same technique, synthetic method, synthetic division. Is there is any missing? 3, 2, 1 and constant. No missing. So I will take the coefficient 1, 2, minus 5, minus 6. And since it is given along with the x, I have to change this 2. 0, 1. Multiply, you will get 2. Add it, 4. Multiply, it is 8. Add it, it is plus 3. Multiply, it become minus, it will become plus 6. So minus 6 plus 6, it becomes 0. Now I will say P of 2 is equal 0. Therefore the remainder is 0. We will say this x minus 2 is factor of P of x. Now let us go to the last problem here. Yeah. Now I want to check this one. So check whether there is missing 3, 2, 1, the power of x. So there is no missing term. So I write it here 2, 1, minus 3 and 1, minus 1. So since it is given as a factor, I have to change the sign. Minus 1, 0, 2. Multiply, minus 2. Add it, minus 1. Multiply, it become plus 1, minus 2. When you multiply, it become plus 2. Therefore, the remainder is 1, not as a 0. Therefore, I will say x to the p of minus 1 is equal 1, not equal 0. Not equal 0. Therefore, it is not a factor. It is not a factor. X plus 1 is not factor of p of x. Why? The reason is the remainder is not 0. The remainder is not 0. So if it is a factor, it must be half. The remainder must be 0. Otherwise, it's not a factor of the polynomial. So this is a summary of all the thing. So if a polynomial p of x is divided by the factor x minus c, then the remainder equal to p of c is the remainder theorem. This is the remainder theorem. This is a whole summary of this one. This is the remainder theorem says. And here if you will get 0, the remainder is a factor theorem. And similarly, you can calculate the zeros of the polynomial in our upcoming chapters. Thank you.